Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the concept related to electric vehicles and hybrid electric vehicles. In the previous tutorial, we have seen the implementation for the buck converter. We've seen how to implement the same in MATLAB. Along with that, we have a look into the conceptual understanding for the buck converter. In case you want to have a look into the same, please have a look into the previous video in this particular series. In this particular tutorial, we will be looking into the discontinuous conduction mode for the buck converter and how the discontinuous conduction mode come into the picture as well. If you see the buck converter, we do have the design like this, and in the buck converter, we do have a load register, which is the 12-volt output register. And it is possible that this register may vary, or the load quantity may vary over the time. We do have this inductor, which is also as per the design parameter that we have defined in the previous tutorial. But if there is a situation where the inductor current is becoming negative or becoming zero, then the behavior of the buck converter will be little bit different compared to the usual behavior that we have. So that is the concept behind making this video. And so this particular uh, video contains related concept to the same. So as you can see in the circuit, we do have the diode, and it always allow a current in the positive direction, the same current direction in which you have while you are at switch on. It should be the same when you are at switch off. There will be no negative current flowing through the circuit because of the diode will be blocking the negative current. In the initial stage, like when you switch on, whichever the current flow is there, same current flow should be maintained in the inductor or in the entire circuit because of the diode opposing the reversal of the current. So coming to the different modes of operation. So first is the continuous conduction mode, and in this mode you do have two states. One is the on and one is off. And in this state you will always find a inductor current always positive. So due to this, inductor tries to build up the voltage. As you can see, it is varying from 5 amps to 10 amps. And next is the critical transition mode, where you will be entering into this critical transition mode where your load is increased. Now you can see the current is varying between positive and zero. It is not becoming negative. So it is hitting zero, and that's why it is the critical mode, and it is varying from 0 to 5 amps. Coming to the discontinuous conduction mode, in this case, the current tries to get negative at the beginning, but whenever it tries to get negative, the diode blocks the current, and at that moment you can see the discontinuity of the buck converter current, and that is why you get this discontinuous conduction mode. And overall you get three modes in the buck converter. First is the continuous conduction mode, which you can see like it is varying from 5 amps to 10 amps. Next is the critical transition mode, where you are transitioning from continuous conduction mode to discontinuous conduction mode. You can see in the graph it is like 5 amps to 0 amps. It is not getting negative. And you can see in the last graph that you have the discontinuous conduction mode, where you have a 2.5 amps to 0 amp variation, and this 2.5 amps to 0 amp variation is happening. Before that, you can see the voltage was negative, and the current was also trying to align it in a negative direction. But if you see the discontinuous conduction mode, there the diode tries to oppose it, and there you will be finding there is no current because the diode is completely blocking the current which is coming in the negative direction. And to determine this condition, like when we will come to this situation, we need to analyze a little bit on the circuit, and we need to derive like which are the main components. Basically, these components are either it will be an inductor, which we need to choose based on our load, or based on our inductor that we are using in the buck converter, we need to choose our load range. If we do not choose it within the range, then we will enter into the discontinuous conduction mode, and there our buck converter will be like having no current in the discontinuous zone, which you are able to see in the screen. So at that moment it will like behave weird, and you will not get the desired buck behavior in the converter. So coming back again to the critical transition mode. So here you see like the current is rising and it is hitting 0, and then again it is rising to a positive value. And this is happening because there is no negative current flowing in the system, but it is becoming 0. The same you can derive with the help of these formulas. Like if you decide like one of the quantity, like if you decided your inductance already, then you can decide like how much load you can maximally apply. So that is the resistance, and R critic is the resistance which you can maximally apply. If you cross this, then you will enter into the discontinuous conduction mode, and the formula for this one is 2L 1 minus d Ts. So this is the formula, and in this, if you see, R critic is the critical resistance that is helping you to enter into the DCM mode, and L is the inductance of the circuit that you already have, and D is the duty cycle, and Ts is the overall switching time. Like it is like 1 divisible by frequency, switching frequency. Again, coming to the decision for the inductance, if you see, you have another formula for the critical inductance. If we choose the inductance as 1 minus dr Ts divisible by 2, then based on this, like we are already here deciding our load, that we will be using this much resistance in our load, and based on that we are deciding how much inductance we need to add in the system. That way, basically, we will be present in the critical mode, which we already seen in the screen now, where we are not going into a negative direction in which like the diode is blocking the current and the current is 0 for some instant of time, and then again we are getting some current in the inductor. So that is an undesired behavior which we are basically avoiding by determining R critic and L critic. So coming to the discontinuous conduction mode. So if you see the discontinuous conduction mode, we already now decided the quantity for R critic and L critic. As you can see in the graph, a good amount of duration of time is having a 0 current in the buck converter. Due to the inductance and the resistance, and due to that we are getting the discontinuous conduction mode. And the discontinuous conduction mode will be achieved if your resistance is greater than R critic, and if your inductance is lower than your L critic. This is happening just because the diode is not allowing the reversal of the current, and that is also a safety mechanism that is there for the buck converter. And we are entering into the discontinuous conduction mode, and due to this the behavior of the buck converter is affected, and we will be getting a weird behavior while lowering the voltage down. So overall we seen 3 modes for the buck converter. First is the continuous conduction mode, where there is no negative current or 0 current in this mode. for the inductance. Next is the critical conduction mode, where you are transitioning from CCM to DCM. And then you have this DCM, discontinuous conduction mode, for the buck converter. So overall, it looks like this. You do have three states, and the buck converter transits from one state to another state based on the resistance or the inductance that you have used for the buck converter. So coming to the implementation part, now we will be having a look into the MATLAB implementation that we will be doing, and we will be analyzing the graphs based on this analysis. So overall, in a summary, we see in the three modes, and we will be implementing this in the MATLAB environment. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts, and happy learning MATLAB. Take care.